Hello, ladies and gentlemen, Root Beer here, and we're going to be looking at question number 17 in this video. Question 17, of course, from the 2017 Fermat paper. Aaron has 144 identical cubes, each with edge length 1 centimeter. Okay. He uses all of the cubes to construct a solid rectangular prism. Not necessarily, 144, it's got a lot of factors of 2 and 3. I was about to say it's a cube. It's not. It's a square. 1728 is the cube of 12. But it doesn't matter because he's not making a cube. He's making a rectangular prism. So he lies this on a flat table. If the perimeter of the base of the prism is 20 centimeters, what is the sum of all possible heights of the prism? Ooh, okay. So let's draw a picture here. So we have a rectangular prism, and it has length, width, and height. I'm going to call these x, y, and z. These are our dimensions. Okay. And so we know 144 cubes makes everything up, but and so that's the volume, 144 centimeters cubed. But that's going to be the same as x times y times z. Okay, so that's a piece of information that we have, because it's a rectangular prism. What else can we say? Well, we know the perimeter of the base, which is going to be x plus y plus another x at the back plus another y at the back. So we know that perimeter, 20 centimeters, is 2 times x plus y. Okay. So we can rearrange that and say 10 centimeters is x plus y. And now what we want is the sum of all possible values of z. Okay. What can we do? Well, we could take this second equation and rearrange and solve for x in terms of y. Plug that back in up here. But I know x, y, and z are all integers. Okay. So that means they're all factors of 144. So, x, y, they're both factors of 144, but they both have to add up to 10. So I think I'm probably safer in making a nice little chart. How best do I want to do this? So, how about we list out the factors of 144, and there's going to be a lot of them, because it's 12 squared, which is 2 to the 2 squared, times 3 squared. So there's going to be 4 plus 1, 5, times 2 plus 1, 3. So 5 times 3, there's going to be 15 factors here. So we do that sort of calculation so we know if we've missed one. That's the whole point. 6, 8, 9, not 10, not 11, definitely 12, 16, 18. So at this point, once we've hit the 12, we're at the halfway mark. So I can just divide 144 by everything before. It's 144 divided by 6 is going to be 2 to the 3 times, so it's going to be 24. Divide it by 4, it's going to be 36. Divide it by 3, it's going to be 48. Divided by 2, it's going to be 72, and then 144. Okay. Now we're looking for two factors which add up to 10. So I can ignore all of these ones. Okay. And I could say, okay, well, if x is 1, then y would be 10 minus x, which is 9, and yeah, that's another factor. And if that's the case, then what's z? Well, it's 144 divided by x divided by y, so it's going to be 16. Could x be 2? Well, then y would have to be 8, but that's fine. And so 2 times 8, z's going to be 9 in this case. Could x be 3? Well, no, because y is 10 minus x, so y would have to be 7, but 7's not a factor, it's missing. So that doesn't work. How about x is 4? Well, yeah, y would be 6 in that case. And so 4 times 6, 24. Z is going to be 6. And then, yeah, you could have x is 6, but then y would be 4, and you'd get the same z value. So we don't need to go any further. And we only have these three heights, these three z values. So 16 plus 9 is 25, plus 6, we get a sum of 31. And that should be our answer. 31, is that a possibility? Yep, there it is. A. And it's the highest one as well. So we know we didn't miss anything, because that would push the answer even higher. And there isn't a higher possible answer. All right. So that wraps up our question quite nicely. And in the next video, we're going to go through question 18. Take care till then.